Something truly extraordinary has just graced our cosmic neighborhood. A traveler from a distant star system, a comet named 3I Atlas, has swept through our solar system, offering a fleeting but profound glimpse beyond our sun's reach. It is a messenger from the void, carrying secrets from an unknown stellar nursery light years away. This celestial nomad is only the third object of its kind we have ever confirmed, a genuine interstellar visitor. For a brief, brilliant moment, our planetary system was shown not as an isolated island, but a shoreline on a much grander cosmic ocean, with waves that occasionally deliver astonishing gifts to our doorstep. The story reached a dramatic climax on October 3rd, 2025. On that day, the comet made an exceptionally close pass of Mars. It was a moment of scientific opportunity and a held breath across the astronomical community. The comet, a colossal ball of ice and rock forged in the crucible of another star, did not collide with the red planet. It caused no harm, no disruption to the delicate robotic explorers stationed there. Instead, it sailed past like a majestic ship in the night, close enough for our instruments to get an unprecedented look, yet distant enough to remain a beautiful, transient spectacle in the Martian sky. More than a pretty light show, it was a landmark moment for planetary science. A unique, perhaps once-in-a-generation chance to study an object from another part of the galaxy, using the sophisticated fleet of orbiters and rovers we have assembled around Mars. It transformed the red planet into a frontline observatory, a watchtower perfectly positioned to intercept and analyze this alien object. Our first awareness of this cosmic interloper came on July 1st, 2025. Telescopes participating in the Asteroid Terrestrial Impact Last Alert System, or ATLAS, spotted a faint, fast-moving object. It was initially cataloged under the designation C/2025N1, but its trajectory soon revealed its extraordinary origin. It was moving at a blistering pace of 61 kilometers per second, a speed far too great for it to be gravitationally tethered to our sun. This immense velocity is the defining characteristic of an interstellar object. It possesses enough energy to escape the sun's pull, meaning it arrived on a one-way journey from the depths of interstellar space and is destined to return there. The term interstellar itself carries a weight of immense significance. It means, quite simply, between the stars. Unlike the comets we are familiar with, which originate in the cold, distant regions of our own solar system like the Oort cloud, 3I Atlas began its existence in orbit around another star. At some point in the distant past, a gravitational disturbance ejected it from its home system, sending it on an unfathomably long voyage across the galaxy. For millions of years, perhaps billions of years, it drifted through the cold, dark emptiness, a silent witness to the cosmic ages, before chance and gravity guided it toward our sun. Initial estimates suggest that the nucleus of 3I Atlas could be as large as 5 kilometers in diameter. As it drew closer to the warmth of our sun, the most anticipated chapter in the comet's visit unfolded on October 3rd, 2025, when its path brought it remarkably close to Mars. The moment of closest approach saw 3I Atlas pass at a distance of approximately 0.19 astronomical units from the red planet. That number, while sounding technical, translates to about 29 million kilometers. While this is a vast distance in human terms, on the scale of the solar system, it was an incredibly close encounter. It was a near miss in the grandest sense, a cosmic ballet where the two bodies passed without incident, yet near enough for an intimate scientific portrait. To appreciate the scale, use the Earth-Moon distance. The comet passed Mars at roughly 75 times that span. Imagine stacking 75 moons out from Mars. That's where 3I Atlas was. This proximity was a stroke of incredible luck. The comet would appear far brighter and larger in the Martian sky than from Earth, giving robotic explorers a much clearer view. Not just a spectacle, a critical opportunity for science. From Earth, the faint light is hard to analyze, but at this reduced distance, the signals were far stronger. Gases streaming from the nucleus would be more concentrated. Dust would also be easier for sensitive spectrometers to detect and dissect. It allowed our instruments to effectively get a sniff of an alien atmosphere, analyzing its chemical makeup in unprecedented detail. Mars became a partner in discovery, a planetary-sized scientific platform. The flyby was harmless and beautiful. There was never any danger of a collision. The comet's trajectory was well understood and precisely calculated weeks in advance. Mars and its robotic inhabitants felt no physical effects, no gravitational tugs, no atmospheric disturbances. The only impact was the flood of invaluable data sent back to Earth, and breathtaking images of a ghostly green visitor streaking through the thin Martian sky. It was the perfect scientific scenario. All of the reward with none of the risk, a front-row seat to a rare cosmic event. Section 4. A fleet of robotic eyes on Mars. As 3i Atlas approached, a remarkable and unprecedented observation campaign swung into action. Mars, with its constellation of orbiters and its hardy rovers on the surface, became humanity's advance outpost for studying this interstellar object. This diverse team of robotic explorers, operated by space agencies from around the world, worked in concert, each contributing a unique piece to the scientific puzzle. It was a beautiful demonstration of international collaboration and the versatility of the machines we have sent to explore our planetary neighbor, turning them into a powerful, multifaceted, astronomical observatory. High above the red sands, several orbiters turned their instruments toward the passing comet. ExoMars Trace Gas Orbiter used its sensitive spectrometers to hunt for the chemical fingerprints of water and other gases in the comet's coma. Its primary mission is to study the Martian atmosphere, but its tools were perfectly suited to analyzing the thin, gaseous envelope of this alien visitor. Meanwhile, Mars Express pointed its cameras, capturing images to help track the comet's brightness and the development of its tail, adding to a long legacy of planetary observation. NASA's assets provided some of the most detailed views. Mars Reconnaissance Orbiter with HiRISE was tasked with capturing incredibly sharp images. Scientists hoped HiRISE could resolve fine details in the inner coma, and perhaps even glean information about the structure of the nucleus itself. Down on the surface, in Jezero Crater, Perseverance tilted its cameras to the sky. It captured images of a faint, ethereal glow, the signature of the comet's passage, painted across the dark Martian night. The global nature of this effort was further highlighted by other spacefaring nations. China's Tianwen-1 orbiter, United Arab Emirates' Hope probe both joined the campaign, focusing observations in the ultraviolet spectrum. Ultraviolet light is particularly useful for detecting certain elements, hydrogen, oxygen, that are invisible in the visible spectrum, providing another crucial layer of information about the comet's composition. From Mars, the comet appeared brighter and more dynamic than from Earth, giving this international fleet a superior view and cementing the flyby as a landmark event in multi-spacecraft astronomy. Section 5. Whispers from Another Star System, the Scientific Harvest. The torrent of data sent back from the Mars fleet has already yielded a treasure trove of scientific discoveries, offering us our first detailed look at the makeup of an object from another star system. The initial findings are both reassuringly familiar and tantalizingly strange, painting a complex picture of this interstellar traveler. Each piece of information is a clue, not just to the nature of 3i Atlas itself, but to the environment of the unknown star system where it was born millions of years ago, a place we can now study without ever leaving our own. One of the most significant early confirmations was the unambiguous detection of water ice. Spectrometers on the orbiters identified the characteristic signature of water molecules sublimating from the nucleus. This tells us that, like the comets of our own solar system, 3i Atlas is a reservoir of frozen water, an ingredient essential for life as we know it. The fact that it retained this ice over its unimaginably long journey through the cold vacuum of interstellar space is a crucial piece of data for models of how comets survive such epic voyages between stars. However, the chemistry of the comet also presented a puzzle. Preliminary analysis revealed that 3I Atlas seems to have a lower abundance of long-chain carbon molecules compared to many comets native to our solar system. These complex organic compounds are often considered potential building blocks for life. Their relative scarcity could mean a few things. Perhaps the star system it came from had a different chemical composition, or perhaps the intense cosmic radiation it endured during its long trip broke down these larger molecules into simpler ones. Either possibility offers a fascinating insight into galactic chemistry. The physical characteristics of the comet also told a story. The dust tail was observed to have a broad, fan-like shape, which provides clues about the way gas and dust are being ejected from jets on the surface of the rotating nucleus. The shape and behavior of this tail allows scientists to model the size and velocity of the dust grains being shed by the comet. Furthermore, the very orbit of the comet was a statistical anomaly. Its path was nearly flat relative to the plane of the solar system, and its passage so close to Mars was an event with a calculated probability of just 0.005%. This extreme unlikelihood reinforces that this was a chance encounter of the most extraordinary kind. Section 6. A Fiery Farewell. The Comet's Journey to the Sun. The close pass of Mars was not the end of the story for 3I Atlas. It was the prelude to its most dramatic performance. After leaving the red planet in its wake, the comet plunged inward toward the heart of our solar system. Its trajectory is carrying it toward perihelion, the point in its orbit closest to the Sun. This is happening right now, around October 29th and October 30th, 2025. The comet is about 1.4 astronomical units from the Sun, where the Sun's heat and radiation are most intense. Perihelion is a critical time for cometary science. As a comet nears the Sun, increasing solar energy drives its activity to surge. The ices on its surface sublimate faster, releasing enormous plumes of gas and plumes of dust. The coma can swell to immense proportions, and the tail grows longer and more brilliant. Scientists on Earth are pointing every available telescope at 3I Atlas, watching for changes and gathering material to study its internal structure and composition. There is always an element of unpredictability when a comet meets the Sun. Intense thermal stress and the powerful solar wind can trigger dramatic outbursts. The comet can suddenly brighten as fresh pockets of volatile ice are exposed and flash into gas. In extreme cases, gravitational forces and thermal forces can break the nucleus apart, causing disintegration. Whether 3I Atlas survives intact or breaks apart, either outcome gives priceless data on interstellar comet structure. As it loops around the Sun, the comet will begin its long journey back out, never to return. This fiery climax is our last best chance to study it up close. The perihelion data will complement Mars observations, giving a complete picture of how an interstellar comet behaves in a star system. A final, spectacular farewell, a brilliant flash of light before it slips back into the darkness between the stars. Section 7. The Cosmic Doorstep, What 3I Atlas Leaves Behind. The passage of 3I Atlas was fleeting, a momentary ripple in the cosmic pond, but its legacy will endure for decades in the data it left behind. This encounter was a powerful demonstration that our investments in space exploration have prepared us for the unexpected. The ability of our Mars-based robots to pivot from their primary missions and work together as a cohesive observatory proves we are ready to seize rare scientific opportunities whenever and wherever they arise. It shows that we can study the very fabric of the galaxy, the material from other stars, without ever having to leave our own cosmic backyard. This flyby serves as a profound reminder that our solar system is not a closed, isolated bubble. It is an open system, constantly interacting with the wider galactic environment. Objects forged in distant star systems can and do wander into our territory, bringing with them physical samples of places we can only dream of visiting. Comets like 3I Atlas are messengers, carrying clues about the diversity of planetary formation across the galaxy. Each one helps us piece together the grand narrative of how worlds are built and whether the chemical ingredients for life are widespread throughout the cosmos. 3I Atlas did not bring destruction or chaos. It brought knowledge and wonder. It did not threaten Mars, but instead transformed it into a temporary scientific outpost of unparalleled capability. It allowed our machines to perform new kinds of science, to test their limits, and to capture data that was simply unimaginable a generation ago. The comet opened a small window onto the vastness of the universe and allowed us to peer through, confirming that the universe is a place of endless movement, connection, and surprise. The data will be analyzed for years to come, with new papers and new insights surely waiting to be uncovered. And so, as 3I Atlas begins its long, silent journey back into the interstellar void, we are left with a sense of awe and a renewed spirit of curiosity. It was a gift from the galaxy, a random encounter that has enriched our understanding of the universe. It leaves us with a feeling of anticipation, a thrilling sense of readiness for the next unexpected visitor to cross our cosmic doorstep. We will keep watching the skies because the story of our universe is still being written, one interstellar visitor at a time. What secrets will the next one bring? 3I Atlas didn't wreck Mars, it rocked it, proving our solar system's got interstellar neighbors dropping by for science parties. Grab popcorn, the galaxy's streaming live.